Hey there, welcome to a video on section 8.3, which is titled Graph General Rational Functions. Now in this video, I don't want to make it too long, so I'm not going to go into the theory behind graphing general rational functions. I feel that's best if we do that in person, so I can go over the theory just like I went over the theory with graphing simple rational functions the last time we met. So we're just going to go straight to a couple examples, and that'll be at the end of the video, and that way you'll have a chance to do some practice problems at the beginning of next week. And for periods A, B, and D, I won't be there. You'll have a sub. So I just want to give you the nuts and bolts, so at least you can generate the graphs, and I can go over the theory with you guys next time I'm on campus. The good thing is that you will have a math teacher as your sub for periods A, B, or D, so they could guide you through this process if you are a little stuck. But let's just jump straight to our first example. So this is a rational function because you do see a ratio of two expressions. You see 6 in the numerator, x squared plus 1 in the denominator. So here, again, I'll give you the nuts and bolts. And we're going to use red today in spirit of the Niners playing tomorrow in the Super Bowl. So, step 1. Step 1 will be to find your y-intercept. Step 2 will be to find your x-intercept. Step 3, find your vertical asymptote. Step 4, find your horizontal asymptote. And then finally, step 5. Well, actually, I shouldn't say finally, but it's close. We're going to do a sign chart. And then step 6, draw your graph. So it's a 6-step process. So for number 1 here, y equals 6 over x squared plus 1. So for step 1, to find the y-intercept, what you want to do is plug in 0 for x. So if we do that, you get 6 over 0 squared plus 1, so we get 6. That's easy. Step 2, remember when you want an x-intercept, y equals 0 for x-intercepts. So essentially what you're going to do is you're going to set the equation equal to 0 and solve for x. So 0 equals 6 over x squared plus 1. Well, in this case, there'll be no solution. Why? Because your numerator cannot equal 0. The numerator is a constant, so it's impossible to make that fraction equal to 0. So there are no x-intercepts. Step 3. So you want to set the denominator equal to 0 and solve for x. So if we do that, you get x squared equals negative 1. X will be imaginary. So in this case, there's no vertical asymptote, no x-intercepts, and again, our y-intercept is 6. Okay, so we're halfway there. Step 4 is going to be a bit tricky. So to find a horizontal asymptote, you must consider 3 cases. So we're going to scroll up to the first page. And here are the 3 cases to consider. And to be more specific, We'll call this n behavior asymptotes. So what you want to do is you want to focus on the degree for both numerator and denominator. If the degree of the numerator is less than the degree of the denominator, remember degree is the highest exponent. For numerator and denominator. If m is less than n, you're going to have y equals 0 as your horizontal asymptotes. If m equals n, it's going to be y equals a over b, which is the ratio of the leading coefficients. M is greater than n, there'll be no horizontal asymptotes. There's actually a special case when m is greater than n. We'll talk about that when I come back to campus. So, going back to example 1, in this case, m is 0 and n is 2. The reason why is because there's no x. So it's like saying x to the 0 power. So the degree is 0 for the numerator. Degree is 2 for the denominator. So this is case 1. So HA is y equals 0. And I'll explain the theory as to why that's true when I see you guys again. Otherwise, this video is going to be really long. But just trust me, it's going to be y equals 0. Okay, step 5, we do a sign chart. Now for the sign chart, boundaries are determined by x-intercepts and vertical asymptotes. This is very, very important. Your boundaries will be determined by x-intercepts and vertical asymptotes. Again, I'll explain why that's the case, the theory behind it, when I see you guys again. But we have no x-intercepts and we have no vertical asymptotes. So in this case, there are no boundaries. So if I were to plug in any number, it's always going to be positive, right? If I plug in 0, I get 6. Plug in 1, I get 6 over 2. I plug in -1, I still get 6 over 2. So graph is always positive. So in step 6, now we're going to make the graph. Let's make a few tick marks. Remember our y-intercept was 6. Okay, I'm going to change colors up a little bit. So we do have a horizontal asymptote y equals 0. We have no vertical asymptote. We have no x-intercepts. We have a y-intercept right there. And the graph is always positive. Now because of the asymptotes, we're going to expect the left end and right ends to be going against the asymptotes. That's what we call an n behavior asymptote. And the graph will probably look something like that. How high it goes, how low it goes, we're not totally sure. But make sure it doesn't go below the x-axis because of the sign chart. And make sure it crosses the y-axis at 6 because of the y-intercept. It doesn't cross the x-axis, no x-intercepts, no vertical asymptotes. And left and right ends have to be going against the horizontal asymptote there. Alright, let's try one more and the video's over. So in this case, y equals 2x squared over x squared minus 9. So what we want to do here again, step 1. Step 1, plug in 0 in for x. So I'm getting 0. So that's your y-intercept. Step 2, set the equation equal to 0. Well, if you cross multiply, you wind up getting 0 equals 2x squared, because 0 times x squared minus 9 will go away. So x is still 0 for the x-intercept. And if the y-intercept is 0, obviously you expect the x-intercept to also be 0. Step 3, vertical asymptotes. Set the denominator equal to 0. Solve for x. You get plus or minus 3. So you're going to have 2 vertical asymptotes. Step 4. Now this is going to be case 2. See, before we had case 1, because m is less than n, here m equals 2 and n equals 2. When they're the same, you're going to have a horizontal asymptote y equals a over b, or in this case your a is 2, and here your a equals 1. So y equals 2 is your horizontal asymptotes. Step 5, we're going to do a sign chart. We have 0 in the middle, 3 and negative 3. So we're going to start testing points now. We're going to test negative 4, we're going to test negative 1, we're going to test 1, test 4. When I say test, we're going to plug back into the original equation. So if I plug negative 4 in, I will get a positive value for y. If I plug in negative 1 in, I get a negative value. Likewise, if I plug 1 in, if I plug 4 in, I get back to being positive. And remember, at negative 3 and 3, y is undefined, and at 0, y is 0. So now we make our graph. In step 6, one, two, three, four, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Let's draw in the asymptotes. Remember, 1's at negative 3, 1's at positive 3. Horizontal asymptote y equals 2. X and y intercepts both at 0. Now we want the graph to be positive when it's left to negative 3. So it's going to look like this, because you can't have it below the horizontal asymptote, otherwise it's going to be crossing the x-axis, and it's going to be a negative y value. And remember, we don't have any more x-intercepts. Now it's got to be negative in between negative 3 and 3, so it's going to be like a little parabola. And remember, there's a reason why we have the asymptotes. For the vertical, they have to go towards infinity, or negative infinity in this case. And lastly, you want it to be positive on the right of 3, so that's why it goes above the horizontal asymptote there. Okay, we're all set. I'm not going to ask you to do a domain and range for these kind of problems because they're a little tough. When you get to calculus, you'll probably be able to do that just simply because you'll learn how to find maximum minimum points analytically. So that covers the video. Have a great weekend. Enjoy the Super Bowl on Sunday. And I'll see you guys on Tuesday or Wednesday, depending on what period you have. Okay, take care. Bye.